everyone, myself Sravanthi, working as an assistant professor in MLR Institute of Technology. Today our topic is SLR of one parser. So we are going to discuss here what is SLR of one parser and what are the steps that are needed to construct a SLR parser table, and with an example we will be discussing here. So what is SLR parser? So LR parser is also called as SLR parser. SLR parser is nothing but simple LR parser. It is called as, we can abbreviate it as simple LR parser. SLR parser is nothing but simple LR parser. It is the weakest of the three methods. So what are the three methods? LR of 0, CLR, LALR. So when compared to those three methods, it is the weakest, but it is very easy to implement. A grammar for which SLR parser can be constructed is called SLR grammar. So here LR of 0 and SLR of 1 are constructed based on LR of 0 parser. So there are four types of parsers we have: LR of 0, SLR of 1, LALR of 1, CLR of 1. So these are the four parsers we have. So these two are constructed based on LR of 0 parser. These two are constructed based on LR of 1 parser. These two are constructed based on LR of 0 parser, and that is constructed based on LR of 1 parser. SLR is nothing but simple LR parser. It is the weakest over the three parsers which we have. So what are the steps that are required to construct a SLR parser? So first we need to take the grammar, the context-free grammar. The context-free grammar is converted to augmented grammar. After converting it into augmented grammar, insert dot at the beginning of RHS of all the predictions, and find the LR of 0 canonical list of items. We are going to find the list of items, and then after we are going to have the fourth step is we need to find the follow of LHS of productions. We are going to find first time follow for the LHS productions. Next, construct SLR of 0 parsing table. Construct SLR of 0 parsing table. By define SLR of 1 parsing table, by defining two functions. What are the two functions which we are going to define? Go to function and action function. Go to function and action function. So these are the two functions which we are going to define over here. So the first one is augmented grammar. So augmented grammar consisting of, it is a grammar with starting symbol S, a grammar G with start symbol S. When coming to the augmented grammar, G dash, it consisting of S dash. A augmented grammar is a grammar with a new starting symbol S dash. So the production will be S dash tends to S. S dash tends to S. So the purpose of this new starting symbol, nothing but new augmented grammar, is to indicate that when to stop the parsing. It tells us that when to stop the parsing. It indicates us. The dot first indicates that it is already read by the compiler. After S, there is a dot. This dot indicates that it is yet to be read by the compiler. It is yet to be read by the compiler. So we are going for the example. The first step we have is, first we need to find the context-free grammar. Next we need to find the context-free grammar is converted into augmented grammar. Then insert dots at the beginning of the production and find the LR of 0 items. And next you need to find the follow for the given grammar. And next we need to construct the SLR of 1 parsing table by using the two functions. Augmented grammar is completed. So here the production is there. S tends to AA, A tends to AA or B. So the first augmented grammar is nothing but we are going to write here. I am going to write over here. So the augmented grammar is S dash tends to S, S tends to AA, A tends to AA or B. We can also write it as AA or B instead of that directly. I'll write here at the dot. It will be easy for us. A tends to B. A tends to B. So this is my augmented grammar. Now for these augmented grammar, now we are going to construct we are going to insert dots at the beginning of the productions and we are going to mention it with a new state I naught. S dash tends to dot S tends to dot A tends to A tends to dot B, A tends to dot B, A tends to dot B. So what type of state it is? I naught state. It is the I naught state. Now what we are going to do? We are going to apply the canonical list of items. Nothing but we are going to apply go to function on each state until I won't get a new state. We are going to derive it, so on, until I don't get a new state. Okay. So first let us apply go to function on this I naught. Go to I naught, comma, what is the first symbol I have? Yes. What is the first symbol I have? Yes. So yes is nothing but after dot whatever the production, either it is a terminal or a non-terminal, we are going to apply on that go to function. So here go to I naught comma yes. What it is happening? The dot is moving to the next state. The dot is moving to the next state. Now it is nothing but I1. It is nothing but I1. So next one we are having is go to I naught comma. What is the next production I have? S tends to dot AA. So A is nothing but a non-terminal. So when I am applying go to function on a terminal or a non-terminal, the dot is moving to the next position, next move. So here S tends to A dot A. After dot, we are having the non-terminals are there. Then we are going to write the productions of that non-terminals. If I find a terminal, then we won't have a productions of the terminal. Only for non-terminals, we have the productions. So what are the productions we have for dot after dot A is there? So we need to write the productions of the I naught state. So I naught is having the original productions. So after dot A is there. So what are the productions of A? A tends to dot A tends to dot B. We are not going to apply go to function on the productions which we are going to write for the production A dot A. So as here A is there, it is a non-terminal. We are going to expand that A, but we are not going to apply go to function on it. So this is nothing but I2 state. I got a new state, so we are mentioning it with I2. The next production I am having is go to I naught comma. The next production is A, small a, I naught comma small a. So the next what I am having, what is the production? A tends to, the dot is moving to the next position, A dot A. A dot A. After dot I have a non-terminal, so we need to write the non-terminal productions. A tends to dot A tends to dot B. So what type of state it is? It is a new state. Check once we are writing, we are getting the productions, we need to check whether these productions are already existing in the before functions, in before states. If it is existing, you just replace that state number over here. If we don't find the existing states, then mention it with a new state. Next, go to I naught comma B. The last production I am having is B. So A tends to B dot. A tends to B dot. So this is nothing but I4 state. This is nothing but I4 state. So I have completed reading the I naught productions. We need to read all the productions of each state. I naught production is completed. So the next move to the I1 state. So check whether I1 state is having the productions which are not yet completed. Nothing but the dot is not at the end. I1. This is already completed. Next move to the I2. So go to I2 comma. What I am having? A. After dot, what is that production I am having? Symbol. That symbol we need to write here. So what I am having? S tends to A dot. The dot is moved to the next position and it is reaching my end. So A dot. So what type of state it is? I5. I5. Next, go to I2 comma small a. I2 comma small a. So here what I have? A tends to A dot A. A is there. So it is a non-terminal. So we need to write the non-terminal productions. Dot A tends to dot B. A tends to dot B. Check whether these productions are already existing in the before states. Check. So here, see here in I3 and here when I apply I2 on small a, both are having the same productions. So just write the state number I3. So same I3 is written over here. Next, go to I2 comma B. I2 comma B. So A tends to B dot. A tends to B dot. Check whether this production is existing. Yes, it is in I4. So write I4. I4. Now this go to on I2 state is completed. Now next go for the I3. Go to I3 comma. This is my I3 state. I3 on after dot what I am having capital A terminal, non-terminal. A tends to AA dot. The dot is moved to the next state. So it is completed. So what type of state? I5 is completed. Now I6. I6. Next go to I3 comma small a. Go to I3 comma small a. A tends to A dot A. A tends to dot AA. A tends to dot B. A tends to dot B. Check whether this production is available or not. Yes, it is available. I3. I3. Next. I3. Next, what I have? Go to I3 comma B. I3 comma B. So what I am having? I3 comma B is nothing but A tends to B dot. A tends to B dot. So already that production is existing. So write I4. I4. I3 is completed. Reading. I3 function, applying go to function on I3 is done. Now next go for I4. I4 it is in end of the parser. Dot is at the end. I4 is also completed. Check I5. It is done. I3. Already it is done one. So no need of again and again applying go to function on the same state. I3 is completed. No duplications should be done. I4 it is done. I6 it is done. I3, I4 which I have done. So these are nothing but the canonical list of items. Canonical list of items. For these canonical list of items, we are going to construct the data flow diagram, and the next we are going to find out the SLR of one parsing table. SLR of one parsing table. So first we need to find the data flow diagram. So data flow diagram, first what is the I0 state I am having? I0 state I am having the productions are S dash tends to dot S, S tends to dot AA, A tends to dot AA, A tends to dot B. A tends to dot B. So this is nothing but I0 state. So I0 on S, in which state it is moving? I1. What is the production I have? S dash tends to S dot. S dash tends to S dot. So this is my I1 production. I1 production. So the next what I have? I0 on capital A. Where it is moving? I0 on capital A. S tends to A dot A tends to dot AA, A tends to dot B. This is nothing but I2 state. This is I2 state. Next, I0 on small a. I0 on small a. What are the productions I have? A tends to A dot A tends to dot AA, A tends to dot B. So what state it is? I3. I3. I0 on small b. It is moving to the A tends to B dot. It is I4 state. I4 state. I1, go to function on I1, there is no news. I2, go to I2 on A. I2 on capital A, S tends to AA dot. It is I5. I5. Go to I2 on small a, it is moving to I3 on small a. Go to on small b, it is moving to I4. Instead of writing the same states again and again, we are just plotting it. We are just giving a connection. Nothing but how the data is moving from one to another state. Next, I3. I3 on capital A. I3 on capital A. Where it is moving? A tends to A dot. It is I6. I6. I3 on small a. It is moving to the self. I3 on small a. It is moving to self. I3 on small b. It is moving to I4. I3 on small b. It is moving to I4. Next, I4 is completed. I5 final state. I6 final state. So this is nothing but data flow diagram. From one state to another state, it is moving. So we can also tell it as DFA, right? So this is also, we can call it as a DFA diagram. It looks like a DFA diagram. So the next one we are having is, the next step what we need to do is, we need to construct a parsing table, SLR parsing table. To construct a SLR parsing table, there are two functions we are going to have, action and go to. Action and go to are the things we have. In the go to, we are going to write the non-terminals. In the go to, we are going to write the non-terminals. In the action, we are going to write the terminals. Action consisting of 4 types of actions we have: shift, reduce, accept and error. Here we are going to use 3: shift, reduce and accept. So the start symbol, when it is reaching, in which state it is reaching, we are going to write it as accept for the dollar. It indicates that it reaches the final state. Next, shift, reduce. When I am moving from one, when I am applying go to function on states, it is moving to the another state. When I am applying I0 function, go to function on terminals, it is moving to the next states or same state it may be. So that is nothing but we are going to mention it with yes. We are going to mention it with S. And the reduce is nothing but we are going to apply reduce when the final states. The states which are in final, for that we are going to write the reduce. We are going to write the reduce. Okay. So let us construct the parsing table here. Sorry, this is go to and this is action. Go to, action. How many number of states we have? 6 states are there. So just mention it outside. I0, I1, I2, I3, I4, I5 and I6. So these are the 6 states we have: I0, I1, I2, I3, I4, I5. These are the 6 states we have. So first we will construct the shift and the go to function, then we'll go for reduce. How to do the reduce part? Go to I0 comma S. I0 comma capital S. Capital S is nothing but in the go to. For the non-terminals, we are going to just write, instead of I1 only, just we'll ignore the I and we'll just write the numbers over there. So I0 comma S, where it is moving 1. Go to I0 comma A, which state it is moving? 2. I2. 2 it is. Go to I0 comma small a. Small a is there in action. So action is nothing but we need to write shifts. So what I am having, I3 is nothing but S3. S3. Go to I0 comma B. It is nothing but S4. S4. Next, I1 it is done. Go to I2 comma A. I2 comma capital A. It is moving to number 5. I2 comma small a. It is moving to shift 3. Okay. I2 comma small b. It is moving to S4. It is moving to S4. Next, I3 comma capital A. I3 comma capital A. It is moving to 6. I3 comma capital A. It is moving to 6. I3 comma small a. It is moving to shift 3. I3 comma b. It is moving to shift 4. So this is nothing but shift part is completed. Now check from the canonical list of items, what are the final states we have. So final states how we are going to identify is nothing but when the dot is reaching end of the production. So the first production I1, it is reaching the final. Next I2, it is nothing is there, no production. I4, next I5, next I6. Same production if it is repeating, only we are going to write only once. So these are the final states we have. These are the final states we have. So what we need to do here is, first we need to write the numbers for the original production. We are going to write the numbers for the original production: R1, R2, R3. So these are the 3 productions we have. So R1, R2, R3. So these are the three numbers which I gave our production. So what we are going to do here in SLR is we need to find the follow for the LHS of this production. To find the reduce here, we need to first find out the follow function, first time follow. So first let me write what is the follow for this yes. So to calculate follow, first we need to calculate first. So first of yes. So first of yes, what I am having A. A is nothing but A functions are A comma B. A comma B. Next, first of A. First of A is nothing but A comma B. A comma B. First of yes and A. Next, follow of yes. Follow of yes. As S is my start symbol, there is no production which is available in the right side. So, we are just writing a dollar as it is my start symbol. Next, follow of A. Follow of A. So, what it is? A is following A. So, if A is following A, what we are going to do? We are going to write the first of A. What is first of A? First of A. First of A is nothing but A comma B. A comma B. So, if I am having these one, if I take this first A, then I am going to get this first of A. If I take second A as follow of A, then nothing is there. So, it moves to the follow of yes. What is follow of yes? Dollar. What is follow of yes? Dollar. So, these are nothing but first time follow calculations. First time follow calculations. When I am going to take the first follow of first A, I am going to get A comma B. If I take A as second A, follow of A, there is no symbols after this A. So, if no symbols are there, then what it do? It directly jumps to the LHS part. LHS what I am having? Yes. Follow of yes. What I have written? Follow of yes, dollar. So, the same thing is copied over here. The same thing is copied here. So, these are nothing but first time follow calculation. Now, we need to find the reduction part. So, what are the final states? I1 is my final state. So, check the I1. S dash tends to S dot. So, as it is my start symbol, so I need to write the accept in the dollar state. In the dollar place, I need to write I1 in the dollar. We are going to write it as accept. Why? Because the given string is, the given production is accepted. Why? Because why we are going to write here is as I1 production, I1 state, I am having a start symbol and it is my final state. So, I am going to write here accept. Next, this is completed. Next, I4. Go to the I4 production. So, what is the production I have here in I4? A tends to B dot. A tends to B dot is the production. Go to the original production of this one. A tends to B dot. So, go to this production. So, before that, A tends to B dot. So, what is the LHS part of this A tends to B dot? A tends to B dot. What is the original LHS part I have? A. So, we need to write follow of A. What are the follow of A's for this one? A, B, dollar. So, in the I4, the follow of A is what? A, B, dollar. In the place of these three, what is the reduction number for these A tends to B dot? R3, 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 R3. So, first what we are going to do is check the final state. I4 is my final state. Go to that production. A tends to B dot. What is the reduction number? R3 is my reduction number. And in this production, what is the LHS part? A is the LHS part. So, we have already calculated the follow. You just write follow of A. What are the follow of A? A, B, dollar. In the place of A, B, dollar in my parsing table, we are going to write the reduction number. What is the reduction number? R3, R3, R3. So, I4 is completed. The next one is, what is the final state I have? I5. Go to the I5 state. So, what I am having? S tends to AA dot production. So, check the AA dot production. What is the reduction number? R1 is my reduction number. In the I5, R1 is my reduction number. What is the LHS part of this production? Yes. So, what is we are going to do is follow of yes. What is follow of yes? Dollar. In the place of dollar, what is the reduction number for this I5? S tends to AA dot. It is R1. In the place of dollar, We are just writing the reduction number. We are just writing the reduction number R1. Next, what is the next one? I6. So go to the I6 production. A tends to A dot. So what is the reduction number I have? R2 is my reduction number. I6, R2 is my reduction number. What is the LHS part of this production? A is my production. LHS part production. So what is follow of A? A, B dollar. What we are going to write here? R2, R2, R2. R2, R2, R2. So this is of SLR of one parsing table. This is the SLR of one parsing table. So what is the difference for LR of 0 parsing table and SLR of 1 parsing table is, in the LR of 0 parsing table, we have written directly all the reduction numbers in each final state. Here I4 we got according to this follow function R3. Coming to I5, in the LR of 0 table, we have written here R1, R1 we have written. But here we are going to reduce that. We are going to reduce that. So how we are going to reduce is by applying the follow function. By applying the follow function, we have reduced some reduction steps coming to the LR of 0 table. From the LR of 0 table to the SLR of 1 table, the reduction part is reduced. The reduction part is reduced. So that is the main difference from LR of 0 and SLR of 1. So that is why we are going to tell that this SLR of 1 parser is nothing but simple LR parser, and it is very easy to implement when compared to the remaining parsers, and it is also the weakest one. Okay. So here the main difference is we are going to calculate the follow function. What are the terminals we are going to get in the follow function? In that places in the final steps, there only we are going to plot the reduction numbers. Then only we are going to plot the reduction numbers. So this is of SLR of 1 parsing table. So what are the steps we have discussed here in SLR of 1 parsing table? First, we have constructed the augmented grammar for the given context-free grammar. Then we are going to place the dot functions before the augmented grammar. And then next, we are going to find the canonical list of items which is there here. And next, we are going to find the data flow diagram. And next, we are going to construct the SLR of 1 parsing table. So for each and every grammar is easy to construct a SLR of 1 parsing table or any parsing table. No. See here in the action part, I may get conflicts also, maybe we are going to get. So nothing but in a single column, we may get 2 reductions or 1 shift and 1 reduce. So if we are going to get that type, then we are going to tell that it is not a SLR parsing table or LR of 0 parsing table. In each column, we should get either shift or reduce. We should not get both. If we are going to get both, either shift or 2 shifts or 2 reduce or shift and reduce, then it will be like a conflict. So we don't know that when we are going to plot it, we don't know that which one I need to take. Whether I need to take the S3 shift or whether I need to reduce. Which one I need to opt. If I opt shift, but according to the given parse tree, if I do reduce, then I am going to get the grammar. So that is the conflicts we will be getting. If we, in each column, we should get only one thing, one action, either shift or reduce or accept anything. So if we are going to get more than one action in the action table in each column, then we are going to tell it is not a parsing table. Then we are going to tell it is not a parsing table. We will be discussing